In square ABCD, points P and Q lie on line AD, or segment AD, and segment AB, respectively. Segments BP and CQ intersect at right angles at R, with BR equal to 6 and PR equal to 7. What is the area of the square? I want to focus in on this triangle right here and this triangle here. So all around, these are 90-degree angles, or rather, at least this is a 90-degree angle. And so from here, if I call this angle x, then this angle must be x minus 90. And then since this is a right angle right here, since it's a square, this angle is x. And actually, yes, it is all around. This is a 90-degree angle too, and this is a 90-degree angle. So therefore, up here, this angle must again be x minus 90. And then since this is a 90-degree angle, and this is x minus 90, then this angle has to be x. And then, since this is a square, obviously this side is congruent to that side. We can then reason that triangle APB is congruent to triangle BQC, because if you look at the angles, they all share the x minus 90, and 90 degree, and they have this side is congruent. So these two triangles are congruent by ASA. And so then from that, since we know that this triangle's APB's hypotenuse is 13, we can then reason that the hypotenuse of triangle BQC, QC is going to be 13 as well, because the triangles are congruent. We can then go further, and if we look at triangle RQB, so RQB, this smaller triangle, and then RBC, so RBC, they're similar because they share all the same angles. They have 90x and x minus 90. So then, since these two triangles are similar, we can have, it's got to be true that RB over RQ is equal to corresponding sides RC over RB. And for the purpose of this, we'll just call RC, let's say that's equal to y. So RC is going to be equal to y, and then RQ is just going to be 13 minus y. And so from here, so we know that RB is equal to 6, and RQ we've defined here as 13 minus y. This is equal to y over 6. And if we solve here, we get that 36 is equal to, and we'll just do some manipulation here. So we get y equals 9, y equals 4. Obviously, it just has to be one of these, and it's going to be y equals 9. So again, we defined RC as y. The reason why it's 9 is because we can clearly see that RC is greater than RQ. And if y would be equal to 4, then we would have RQ being greater than RC, which is not true. So y equals 9. And coming back up here, if you look at the triangle RCB, so in RCB, we found that RC is 9. We already have that RB is 6. So to solve for a side of the square, or the hypotenuse of this triangle, it's going to be true that BC is equal to square root of 9 squared plus 6 squared, which is root 117. Therefore, so we found that a side of the square is square root of 117. Therefore, the area of the square is just root 117 times root 117, or root 117 squared. So the area of the square is 117. The answer is choice D.